Welcome to this class, my girls.
Thank you, sir.
Okay. Now, gradually we will be acquainted with the term degree of a polynomial through some given examples. It will be very easy. Please try to solve my questions. Now, look at the picture, look at the chart I am showing here. Here, some given polynomials are written here. First space is kept blank. Supply me a very easy polynomial of degree 2.
X square plus 3x plus 2.
Okay. I have used supply me a polynomial of degree 2. Have you ever heard the term degree?
Yes, sir.
No, I shouldn't use the term degree. Actually, we are very much acquainted with the index of the power.
Yes, sir.
Okay. Instead of using index of the power, I have used intentionally the degree, but it seems to be synonymous. Actually, it is. Let us see. For this expression, this polynomial x square plus 3x plus 2, what are the indices of the powers of x taken in order? Please supply me the indices.
So
2,
1,
1 and 0 for the 3 terms. Okay. Observing this set of value, say me what is the maximum of these 3 numbers?
so
2. Actually, among the indices of the powers of variable concerned here of x, the maximum of the indices will be termed as the degree of the polynomial. So, any power is not the degree. The maximum index of the power stands for the degree of the polynomial. Okay. For the second one, what is the powers? What are the powers?
the powers are 3, 2, 1 and 0.
Again, observe the coefficients of the terms. The first coefficient is 0. Actually, this very term of power index of the power 3 will be absent in the polynomial. So, do not consider this very term to be included in the polynomial. Just forget about it. Okay. Then 3 will be cancelled.
Yes, sir.
3 will be cancelled, and we are left with 3 numbers, namely 2, 1 and 0 for the remaining 3 terms. Okay. What is the maximum among these 3? Maximum is 2. Therefore, the degree of the first polynomial was 2 and the degree of the second polynomial is 2. And what is for the third one? Supply me the indices of the powers of x.
So 1
1,
and 99.
1, 2 and 99. And what is the maximum value?
Maximum index is 99.
Then what is the degree of this polynomial?
The degree of the polynomial is also 99.
99. Okay. I think there is no doubt about the degree of the polynomial.
No, sir.
Okay. Now, we are considering the general expression of the polynomial a0 x to the power n plus a1 x to the power n minus 1 etc. up to n. Now, if we have this term for the maximum power, then actually see the powers, indices of the powers are in reducing series n, n minus 1, n minus 2 etc. If we move to the left, then the index will be increased, and if we move to the right, the index will be decreased. Suppose this will lead to the maximum power. Okay. Then if this index will be the degree of the polynomial, then the coefficients of the terms in the left of this must be 0. Otherwise, the index of the power n minus 2 will not be able to be the maximum. Okay. Suppose in this very expression some term contains x to the power m, x to the power m. Then what will be the suffix of a, which is the coefficient of x to the power m? Just use the fact that the suffix plus index will be n. Suffix plus index will be n. then if we have a term containing x to the power m, then what will be the suffix of a?
M minus m plus n.
Try again. If the index of the power be m, then what will be the suffix of a? Choose it in such a manner that the suffix plus
So
m.
m minus the suffix.
Okay, let us see. M, we have m as the power,
Yes.
and what is the suffix? Question mark, and the result would be n. Sum is fixed.
Yes. Then it
Therefore,
will be
question
m.
mark will be n minus m.
Yes.
Therefore, x to the power m will have the coefficient a n minus m. Okay.
Okay.
So, the coefficient of x to the power m is a n minus m. Therefore, for x to the power m, to be present in the polynomial, the coefficient of x to the power m, namely a n minus m, must not be 0. Otherwise,
Yes.
the term will be absent.
Vanished.
Again, we must have the second condition, that is the coefficients of the power which is higher than m must be absent from the polynomial. Therefore, the coefficients must be zeros.
Yes.
Then, if we put the suffix as j arbitrarily, then for the terms which has the power index of the power greater than m would be, these coefficients would be 0. Okay. These coefficients would be 0 for what values of j?
Less than n minus m.
Less than n minus m. Let me explain. If this is x to the power m, then the terms whose power, whose index of the power is greater than m are lying to the left, and the coefficients, suffix of the coefficients are less than 2. Therefore, we are concerning the x to the power m whose suffix is, whose coefficient is a n minus m. Therefore, suffix is fixed to be n minus m. Therefore, if we move to the left, then the suffix will be less than n minus m. Therefore, those terms having powers greater than m will be vanished by making a j equal to 0. Okay.
Okay, sir.
Therefore, this is the condition, this is the set of conditions for which m will be set to be the power, degree of the polynomial. The conditions are a n minus m, that is the coefficient of x to the power m must not be 0, and the coefficients of the terms having the index of the power greater than m must be 0. This is the general case. Now, we are considering a very simple quadratic polynomial a x square plus b x plus c, where the constants are being kept as arbitrary. You can choose any value for the constants a, b, c. Then my question is that, just tell me the condition or conditions for which we can take 2 as the degree of this very polynomial.
For the first case, it will be a not equal to 0.
A not equal to
0.
0. If we make b 0, c 0, then the degree of the polynomial will remain the same, because the maximum of the degrees will be present there, which is 2 here. And what will be the condition or conditions for which 1 will be the degree of the polynomial? 1
So,
will be the degree.
In that case, both the coefficients a and b has to be 0.
A is 0.
And
If we make a is 0, then the polynomial will be reduced to be b x plus c. If we make b equal to 0, then
No sir, b will not be equal to 0.
b must not be 0,
Yes.
for getting the term b x to be present here, and then 1 will be the maximum of the powers, indices of the powers. Okay. Here the indices of the powers are 1 and 0, because c can be written as c x to the power 0 and the maximum is 1. Therefore, the degree would be 1. Okay. And what are the conditions for which the degree of the polynomial will be 0?
For this case, it will be A and B is equal to 0 and C not equal to 0.
C not equal to 0, because you are getting C
So, C
as
not equal
C
to 0.
into x to the power 0. If we make C equal to 0, then there would be a problem. So, in order to make the term C x to the power 0 to be present there, we should make C non-zero. Therefore, these are the conditions for getting to 1 and 0 as the sequential degrees of this very polynomial. Now, I am supplying the set of conditions in a reverse order and just give me the degree of the polynomial. If we make A, B, C to be 0, here A, B, C are taking to be 0.
0.
Then what will be the degree of this very polynomial? Then the polynomial would be A x square plus B x plus C will be 0, that is the 0 polynomial. Okay. Just think of it, that will be discussed in the coming modules. Okay. Thank you for being here. Thank you once more.